Hello, everyone. Today I'm going to present about network topology optimization using deep reinforcement learning and graph neural network. This is a research I found in IEEE Explore. So first, let's talk about what is network topology. The network topology is about traffic management in the network system. For example, here we have ring topology, which connect into the ring shape, and bus topology that connect in linear shape. So what is optimization of network topology? So you might want to know that the network can increase the performance. So it can increase the speed and stability or tolerance. Can we reduce the cost of setting up the network system? The last one is about the accuracy. So our packet will get to the correct destination or not. So let's start with our first approach, which is path selection with prediction strategy. The first algorithm is random path algorithm. Our goal is to find the best k capacity paths between nodes, so that we will run 100 trials, and each time we will generate a random tree. For each source and node pair, we find the path between them and measure the capacity. In theory, we will have two cases. So the first case is we store fewer than k paths, so the next path can get into our storage. Or it will fall into the case B, that we store k path already. So we will have to kick the weakest part and then store the stronger part in there. Like in the picture, the red house has to leave because the green building is better. The next one is message passing algorithm. So we're going to summarize the whole network topology in one output. At first, we set up the node with hidden state. Then the hidden state contains its own feature value. Next is we processing the message by compute the new stage of itself and neighbors from message sending. Then we update the state. The last one is we output the global vector queue that summarize everything and the updated hidden state of all nodes. We come up to the second approach. The second approach is about step function of activating agent and deactivating agent, so we call dual agent tree topology exploration. The step function of activating agent is about to learn the way to scaling the network topology. In this case, we have the power plant that can produce 120 megawatt hour. So we connect to the system and somehow this Y got deactivated randomly because the algorithm say remove the random link. Then we try to add this one, and the final reward is 0 because we cannot supply all of the system. So we come up with the next algorithm to deactivate the agent effectively. So we have to use the previous agent to add the agents back, and this one say the red house has been removed because I'm inefficient, and if it connect, it will make the electricity exceed the amount of the power plant that can produce. So in summary, we use both step function agents to work together for network topology optimization. As the first one, we growing the tree, and the next one is like we trimming the tree out or pruning. So how is it different for the first approach and the second approach? The first approach does not require that much memory in comparing to the second one, and it is slow but steady. The second one is using high memory and complexity, but it is good for speed and accuracy. If you're comparing them, you can comparing like a truck and a supercar. This is our reference, and this is me, Thanawas. Thank you for listening.